Okay, so we're going to do a standard curve sketching problem, okay? So, part A of the problem is just find the critical points. Okay? And we find these critical points by taking the first derivative and setting the first derivative equal to 0. All right, so what do we get from that? Now f prime of x, that would be now 10 x to the 4th, and then minus 10. Okay, so we got to think, what can we pull out of this thing? Okay, I could pull a 10 out. That's the easiest first step. Okay, now I got to think about how am I going to factor this thing? Well, I can rewrite that as 10 times x squared minus 1 times x squared plus 1. Okay, so at this point of the problem, the only thing that's going to happen with this term over here is the only way to make that into a 0 is to use complex numbers, I or negative I. This can be factored further. All right? So that's going to equal now 10 times x minus 1 times x plus 1 multiplied by x squared plus 1. And remember that whenever we're doing this, we're setting the first derivative equal to 0. Okay? We're not going to get anything from that last component because it's irreducible. So what are our critical points for this problem? Our critical points are going to be x, which equals 1, and x, which equals negative 1. Okay? Okay, so that's the first part of this problem. It's just finding the critical points. All right? So, the second part of the problem asks, okay, so are these critical points maximums or minimums? All right? So, to determine if a critical point is a maximum or a minimum, we're going to do the second derivative test. The second derivative test is the easiest one to do. So let's take the derivative again. All right, so f double prime of x is going to equal 40x cubed. Okay? So f double prime of 1 is going to equal 40, which is greater than 0. Okay, so our second derivative, all right, so the first derivative test says that it's going to be flat at that point. It's talking about the slope. The second derivative test talks about the concavity of the problem. So at 1, we have a positive second derivative. What does that mean? It means this thing is concave up. This is opening upwards and it's flat on bottom. So since it's opening upwards and it's flat on bottom, that means that this guy is going to be a minimum. It's concave up and flat. So this guy is a minimum. Okay. Now we did f double prime of negative 1. Okay. All right. That would come out to negative 40. Which is less than 0. Okay, so what does that really mean? That means that this thing is flat at that point and that it is concave down. It's negative. So since it's concave down and it's flat at top, that means that we are going to get a maximum for those. So since it's negative, we're going to end up with a max. All right. Okay, so the next part of the problem, part C, is finding the inflection point. Okay? So when you're looking for the inflection point, The inflection point, remember, this is the point where it changes from being concave up to concave down, or vice versa. And so what we're going to do is we're going to take the second derivative that describes the concavity, and we're going to set the second derivative equal to 0. Okay, so f double prime of x, which equals now 40x cubed, we're going to set that equal to 0. Okay, so, well, if you divide it by 40, it's still x cubed, which equals 0. If you take the cube root of both sides, cube root of 0 is still 0. And so, what is the inflection point of this problem? That's just x, which equals 0. Okay. All right. Now, the order of this can be debated. I have always done it in this order, but some of the other professors have disagreed with me. Part D, I would say, go ahead and graph. Okay. And the reason that I normally put the graphing part as part D is that the interpretation of the graph is really the next two questions. Okay. All right. So remember, the first thing when you're doing graphing is to plot the critical points. Okay. Remember, whenever you're graphing this thing, you're graphing the original function, so you need to go back to the original function. So the original function that we're dealing with is f of x, which equals 2x to the fifth, now minus 10x. Okay? All right, so now we need to think about our critical points, and let's go ahead and plot those critical points. So f of 1 would be 2 minus 10, which equals negative 8. Okay. And f of negative 1, okay, so if I plug negative 1 into that thing, I'm going to get negative 2 and then plus 10, which is going to be a positive 8. So let's graph those points. This is what we're trying to concentrate. So okay, so here at 1, we're out at 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now here at negative 1, we're at 1, 2, 3, 4, 5, 6, 7, 8. Got my record. Okay. And now we have negative 1 as a max. Positive 1 as a min. Go like that. This guy goes to the origin. All the way down. And there we go. Now we've graphed our polynomial. Okay. And so the next two parts of this problem I can actually fit right here. So we go A, B, C, D, and E. Okay, so we'll ask the question of increasing. So on what x interval is this graph increasing? Okay, well, it's only decreasing in this section right here. So that would be negative infinity to negative 1, and then union 1 to infinity. Okay. And so the decreasing region would just be negative 1 to 1. Okay, now part F is going to ask about the concavity. So where is it concave up? Okay? Remember, the switching of the concavity is determined by the inflection points. So the inflection points can be incorporated whenever you talk about what's concave up and what's concave down. So it's this region right here, that's the U that is pointed upwards. And so that would be 0 to infinity. All right? Then if I ask, well, where is this concave down? Okay. So I'll ask the question of where is my U shape pointed downwards? Okay, that's that part right there. And so that would be negative infinity all the way up to 0. So remember, whenever you're talking about where is it switching from increasing to decreasing, remember from the first derivative test, that actually said that when it goes from positive to negative, negative to positive, that's when you get to a max or a min. So the increasing and decreasing is always going to be separated by your critical points, okay? But whenever you're talking about the concavity switching from up to down or down to up or vice versa, that's always going to be involved with the inflection point. Okay, so that's a full curve sketching problem.